Right, synchronizing pulse. Okay, this is the small video that accompanies the lab that we did in class. I've already done another video on this, maybe even 2 videos on this, but I haven't done one actually at the board. So today we did review this in class and I went through on the board, and here was our circuit that we used. It's our introduction, like it's only in about week 2 of the AC circuit subject, and we used a series RC network. The values that we used there were 0.56 microfarad capacitor, non-polarized. We had 2 volt peak-to-peak sine wave coming in at 500 hertz. And the resistors that we used in the circuit, well, here was the circuit down here. Here's our 0.56 microfarad capacitor, 4700 ohm, 4700 ohms. But if you think about looking into this circuit today, this is a ground for DC and AC. This is an AC ground up here because of the very low impedance of the power supply unit, like maybe 10,000 microfarad capacitor inside it, which great for DC voltage regulation, but for AC, direct short to ground. So therefore, that 47 ohm resistor, 4700 ohm resistor in parallel with that 4700 ohm resistor to give us a total of 2350 ohms in our series circuit. So looking into here, what we have to do first of all is to draw, there's 2 phasor diagrams that are going to be used with this this circuit. One phasor diagram is going to be for the impedance with the resistance of the circuit and the XC of the capacitor. After we've done that, we'll use the impedance to work out the circuit current. Then we'll use the circuit current to work out the voltage across the capacitor and the voltage across the resistor. And then the vectorial addition of those 2 voltages will give us the supply voltage, which of course was 2 volts peak to peak. Alright, so going right into that then, working out the XC first of all. The XC came to 568 ohms, and of course that's given by 1 on 2 pi FC. And because it's a capacitive circuit, we know that the current in the circuit leads the voltage across the capacitor. So we're always going to use, for a capacitive circuit, this quadrant of our phasor diagram. I've plotted on here more or less to scale the 2350 ohms resistance in the circuit, and that is a REQ, an equivalent resistance, because of that AC ground at the top of the circuit. 568 ohms XC. That allowed me then to plot the impedance on there and to calculate the impedance using the square root of R squared plus XC squared, so vectorial addition there, and the impedance came to be 2418 ohms. We know then that looking into this circuit now, we've got this impedance of 2418 ohms. That allows me to go ahead and calculate the current, because we have a circulating AC current in that circuit. And the current was calculated to be 827 microamps, and of course that's done over here. I equals V on R, so 2 volts peak to peak. That'll be 827 microamps peak to peak. Very important not to put there V peak or RMS, because I've started in peak to peak, the answer has to finish in peak to peak. That was the voltage divided by the impedance to give that. And then of course I can go ahead and I can work out the voltage across each one of those components by VC would be equal to that I circuit, which is 827 microamps, times the reactance, times XC. And of course VR, same deal, would be equal to I circuit, the same, times R. That can result then in a second phasor diagram. I've got the first phasor diagram already done then with the impedance. And the second phasor diagram simply would have been a carbon copy of that. Maybe I can quickly do one over here. The axes would be simply labelled different. This would be the current axis, this would be the voltage axis, and in case you're wondering, this would be the the VR of the circuit. This one would be VC of the circuit. And Micah, did you give me those voltages before? For this one that's on the board, did you have a value of VC and VR for this? Or if you've got your calculator there, can you just do it for me? That'd be 2350 times 827 microamps for VR. That 1.94 then was across the resistor. Yeah, 1.94. And VC would be 827 microamps times 568 ohms. 0.469 or 0.47? 470 millivolts. Yep. All right, so that'd be, yeah, about a quarter. That'd be about a quarter of this one over here. So dash, 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 and, oh, at the right angle, there would be my VS in there. Micah, can you do me another favour, and can we confirm that VS, because we're looking for 2 volts peak to peak there, so we should have VS equals the square root of VR squared plus VC squared. So that'd be the 470 millivolts squared plus 1.94 volts squared. Take the square root of that, and that should give us 2 volts peak to peak. Yep, close enough. 1.999999. Fantastic, and that gets the stamp of approval. So, of course, you guys in class, you've done it on, hopefully on graph paper. If you haven't got your graph books yet, don't forget to buy a graph book to do this. You know, you're expected, and that next question that I gave for a class activity as well, you're expected to go ahead and solve XC, Z, IC, draw the Z phasor diagram, draw the voltage phasor diagram. So that's quite a bit of work associated with a circuit which has only got like 2 components, a capacitor and a resistor, and just that AC supply coming in. So that'll probably be the last time that I'll do a video on this one, because I have got quite a few videos like this one done already, but I don't think I had a small, concise one done on the board of this. So I hope that helps. This is Greg Moore for New South Wales TAFE.